Hey everyone, in this video we're going to learn how to graph quadratic functions in standard form. Similar to graphing quadratic functions in factored form, we're going to find the same critical points. Our approach is going to be slightly different. So the directions: graph the following quadratic function by including at least 5 points, determine the domain and range. Our function is f of x equals x squared minus 1. So when we're given a function in standard form, I find the easiest critical point to find is the y-intercept. So we'll start with the y-intercept. That occurs when x equals 0. So we have 0 squared minus 1, which is negative 1. So the y-intercept is the point 0, negative 1. Now from here we can either choose to go axis of symmetry and vertex or the x-intercepts. It makes no difference. So let's look for the x-intercepts next. So those occur when y equals 0, which in this case is f of x. So we'll set the function equal to 0. Now when the function's in standard form, we have to do the factoring. So using the difference of two squares, our factors are x minus 1 times x plus 1 equals 0. So either x minus 1 equals 0 or x plus 1 equals 0. So x equals 1 or x equals negative 1. So the x-intercepts are 1, 0 or negative 1, 0. Next we'll find the axis of symmetry. So we have two choices here. We can find the average of the x values, as we had done in the previous video when the function was in factored form, or we can use x equals negative b over 2a, because the function's in standard form. Because we've already done the average of the x values, I'll choose to use x equals negative b over 2a to practice with this method. So in this case, there is no x term, so b is 0 and a is 1. So we have x equals negative 0 over 2 times 1, which is 0. So our axis of symmetry is x equals 0. So then we can use that to find the vertex. Well, if x equals 0, we've already found what that y value is because that's the y-intercept. So 0, negative 1. So in this particular case, the vertex and the y-intercept happen to be the same point. So we'll plot all the points that we found so far. So we have 0, negative 1, 1, 0, negative 1, 0. But that's only 3 points. We don't have any symmetry because we already have the symmetric points, which are the x-intercepts. So we have to then find another point on our parabola. So let's plug in 2. So we'll figure out what f of 2 is. So that's 2 squared minus 1. So f of 2 is 4 minus 1, which is 3. So we have the point 2, 3 also on our parabolic curve. Now that's 2 to the right of the axis of symmetry, so going 2 to the left of the axis of symmetry, we would also have the point negative 2, 3. And we can connect our points to create our parabolic curve. And then the last thing we have to answer is the domain and range. So the domain here is all reals, negative infinity to infinity. Right, we can plug any x value into our function. And the range, well, the vertex is a minimum point on the curve. So y is any value greater than or equal to negative 1. So we have bracket negative 1 to infinity. Or if you chose to write it as an inequality, you'd write y is greater than or equal to negative 1. Next example, same directions. The function now is y equals negative 2x squared minus 8x. Again, we'll start with the y-intercept, as I find that the easiest point. When x is 0, so we're going to have 0 minus 0, which is 0. So the y-intercept is the point 0, 0. We'll find the x-intercepts next. So we'll set our function equal to 0. We can take a greatest common factor of negative 2x out. So we have x plus 4 equals 0. So either negative 2x equals 0 or x plus 4 equals 0. So either x equals 0 or x equals negative 4. So our x-intercepts are 0, 0, negative 4, 0. Notice one of the x-intercepts is also the y-intercept. So that means we're not going to have as many points when we plot, and we'll deal with that when we get to our graph. We need to find the axis of symmetry in the vertex next. Again, we can find the average of the x values or use negative b over 2a. And I'll stay consistent here using the negative b over 2a. b is negative 8, a is negative 2. So we have the negation of negative 8 over 2 times negative 2. So we have positive 8 over negative 4, which is negative 2. So our axis of symmetry is x equals negative 2. So our vertex is the point with an x value of negative 2. So that's going to be negative 2 times negative 2 squared minus 8 times negative 2. So we have negative 2 times positive 4 plus 16, which is negative 8 plus 16, which is positive 8. So our vertex is negative 2, positive 8. So we can plot all the points we found so far. So we have 0, 0 as both the x and y-intercept. We have another x-intercept at negative 4, 0. We have a vertex at negative 2, positive 8. And those are the only 3 points that we found so far, but we need at least 5 points. So we'll plug in positive 1 for x, negative 1 rather, for x. So if we plug in negative 1, so we have negative 2 times negative 1 squared minus 8 times negative 1. So we have negative 2 times positive 1 plus 8, which is negative 2 plus 8, which is 6. So negative 1, 6 is also a point on our curve. So negative 1, 1, 2, 3, 4, 5, 6. By symmetry, axis of symmetry is at x equals negative 2. So that was to the right one. We'll go to the left one. So the point negative 3, positive 6 is also on the curve. We have at least 5 points now. So there we have the graph of our parabola. And finishing it up, the domain is all reals. And the range, the vertex here, is a maximum point on the curve. So that means we have y values less than or equal to 8. So in interval notation, that would be negative 8, negative infinity to positive 8. Okay, as an inequality, y is less than or equal to 8 would be equivalent. Same directions. Next function is y equals x squared minus 10x plus 21. We'll start with the y-intercept again. So that happens when x equals 0. So we have y equals 21 as the y-intercept. So 0, 21. Next we'll find the x-intercepts. So the x-intercepts, we set the function equal to 0. Now we factor, so the factors are going to be x minus 7 times x minus 3 equals 0. So we have x equals 7 or x equals 3. So we have 7, 0 or 3, 0. Find the axis of symmetry next. So x equals negative b over 2a. So here b is negative 10 and a is 1. So we have the negation of negative 10 over 2 times 1. So that's positive 10 over 2, x equals 5. So the vertex is the point with an x value of 5. So we have y equals 5 squared minus 10 times 5 plus 21. So 25 minus 50 plus 21. Negative 25 plus 21 is negative 4. So we have negative 5, negative 4. So let's plot our points. So we have 7, 0, 3, 0, 5, negative 1, 2, 3, 4. And 0, 21 is the y-intercept, which, unless I scale the axes, I'm not going to be able to fit here. And that's okay. We found that point, but it just wasn't helpful for us actually drawing the parabolic curve. We have 3 points, so if we can find 2 more points, we can still draw this curve. We don't need the y-intercept to be one of those points. So if we plugged in positive 4, so we have y equals 4 squared minus 10 times 4 plus 21. So y equals 16 minus 40 plus 21, which is negative 24 plus 21, which is negative 3. So the point 4, negative 3 is also on our parabolic curve. So 4, negative 3. By symmetry, the point 6, negative 3 is also on the curve. Now we have 5 points, and we can draw our curve. Okay, so this example shows that sometimes those critical points that we get used to finding might not be helpful. Right? We definitely need the x-intercepts and we need the vertex, but the y-intercept, it may not be a point that's helpful. Right? In this case, 0, 21 was just too large. But all we had to do was plug another x value in to get a point, use symmetry, and then we had our 5 points and we can draw our curve. So our domain, all reals, negative infinity to infinity, and our range is from negative 4 to infinity. Next up, we have f of x equals negative x squared plus x plus 6. So we'll start with the y-intercept. So f of 0 equals the negation of 0 squared plus 0 plus 6. So f of 0 equals, let's fix that, looks messy, f of 0 equals 6. Okay, so our y-intercept is the point 0, 6. Next up, we'll find our x-intercepts. So we have negative x squared plus x plus 6 equals 0. So we can factor out a negative 1. X squared minus x minus 6 equals 0. Makes factoring much easier. So our factors, so we need to multiply to negative 6, add to negative 1. So that's negative 3 and positive 2. So either negative 1 equals 0, x minus 3 equals 0, or x plus 2 equals 0. Well, negative 1 doesn't equal 0. X would be 3, or x would be negative 2. So we have 3, 0, negative 2, 0. Next up, we need the axis of symmetry. X equals negative b over 2a. As a reminder, we can find the average of the x-intercepts. So we have b is 1, a is negative 1. So x equals negative 1 over 2 times negative 1, which is negative 1 over negative 2, which is 1/2. So the axis of symmetry is x equals 1/2. So now we'll find the vertex, which is at 1/2, comma. Okay, we have to plug 1/2 into our function. So f of 1/2 equals negative 1/2 squared plus 1/2 plus 6. So we have negative 1 over 4 plus 1/2 plus 6. Common denominator will be really useful here. So that's going to be negative 1/4. Multiply 1/2 by 2 over 2, so that's 2 over 4. And multiply 6 over 1 by 4 over 4, so that's 24 over 4. So that's going to be 25 over 4 as the y value of the vertex. So we can plot all the points that we found so far. So we have 0, 6, 1, 2, 3, 4, 5, 6, 3, 0, negative 2, 0, and then 1/2, 25 over 4. So 24 over 4 is 6. So that's 6 1/4, 6.25. So that's right about there. Okay, so axis symmetry is x equals 1/2. So 0 is 1/2 to the left. So 1/2 to the right is 1. So 1, 6 is another point on our curve. Now we technically have 5 points. So we can draw our parabolic curve. Well, let's see if I can do that one a little nicer. That was a little messy. That's a little better. A little shaky over there. Okay, so the domain is negative infinity to infinity, and the range is negative infinity up to 25 over 4. Okay, so we had some fractions. Vertex wasn't a perfect point. We could have scaled the axes. We could have said each box on the x-axis was 2. That would have fit 1/2 nicely. We were able to estimate it, so both are valid approaches. And then we have that 25 over 4 as the y value of the vertex. Next up, f(x) equals 1/2 x squared plus 5 over 2x plus 2. Okay, function definitely looks more complex, but we'll treat it the same way. We'll start with the y-intercept. So f of 0 equals 1/2 times 0 squared plus 5 over 2 times 0 plus 2. So f of 0 is equal to 2. So our y-intercept is 0, 2. Next up, we'll find the x-intercepts. So 1/2 x squared plus 5 over 2x plus 2 equals 0. In order to factor this, we'll pull out a 1/2, and we'll have x squared plus 5x plus 4 equals 0. So that makes life a lot easier for factoring. So we have 1/2 times x plus 4 times x plus 1 equals 0. So that means either 1/2 equals 0, x plus 4 equals 0, or x plus 1 equals 0. 1/2 doesn't equal 0. We'd have x equals negative 4 or x equals negative 1. So we have negative 4, 0, negative 1, 0 as our x-intercepts. Next up, we got to find that axis of symmetry, x equals negative b over 2a. So in this case, b is 5 over 2 and a is 1/2. So we have x equals negative 5 over 2 times 1/2. So that's negative 5 over 2 divided by 1. So x is negative 5 over 2 as the axis of symmetry. So our vertex is negative 5 over 2, comma. Okay, so we got to plug negative 5 over 2 in. So we have f of negative 5 over 2. That's 1/2 negative 5 over 2 squared plus 5 over 2 times negative 5 over 2 plus 2. So f of negative 5 over 2 equals 1/2 times 25 over 4 minus 25 over 4 plus 2, which is 25 over 8 minus 25 over 4 plus 2. Common denominator is really helpful here, so 25 over 8 we'll multiply by 2 over 2, so we have 50 over 8, and then multiply by 8 over 8, so we have 16 over 8. So that's negative 25, that's going to be negative 9 over 8. So that's not too difficult of a value to use. So we'll plot all of our points. So we have 0, 2. We have negative 4, 0. Negative 1, 0. And then we have negative 5 over 2, negative 9 over 8. So actually, let's scale the x-axis. I didn't last time, so let's do that this time. So we'd have negative 1, negative 2, 2, 4, negative 3, negative 4. Okay, so we have negative 4, 0, negative 1, 0. So the negative 5 over 2, that's negative 2.5. And then we go negative 9 over 8, so that's a little bit lower than negative 1. Right down there. Now by symmetry, negative 5 over 2, the y-intercept is 5 over 2 to the right. So 5 over 2 to the left would be negative 5. So negative 5, comma 2. So we have our 5 points here. And we can draw our parabolic curve. Now, if you didn't scale your axes, your graph would look a little more narrow than mine does. But understand, I've stretched apart the x-axis by scaling it. Okay, so that's going to change the way the graph looks, but now the point fits a little bit nicer. So we'd have the domain of all reals, negative infinity to infinity, and the range is going to be negative 9 over 8 to infinity. Okay, so these problems, we had to factor. That was really the extra step. And we could also use x equals negative b over 2a to find that axis of symmetry. Now one more example. If the point k comma 5 is on the graph of a quadratic function, f of x equals 3x squared plus 10x minus 8, what are all possible values of k? So if we know that this point is on this graph, we can start by plugging in k for x. So we'd have f of k equals 3k squared plus 10 times k minus 8. And if we rewrote the point in function notation, that means f of k equals 5. So we have 5 equals 3k squared plus 10k minus 8. Well, we wound up with a quadratic equation by substituting k and 5 in. So we need it equal to 0. So 0 equals 3k squared plus 10k minus 13. And let's see, can we factor this? It may be difficult to factor, but let's check that discriminant. So the discriminant is b squared, which is 10 squared, minus 4ac. So we have 100 plus 12 times 13, which is 156, which is 256. Okay, so that's a perfect square. So I know I can factor this. So let's use the grouping method. So 3 times negative 13 is negative 39. So we need factors of negative 39 that add to 10. So that's going to be 13 and negative 3. So we're going to have, I'm going to put the equal sign and the 0 on the right side. So I'll have 3k squared plus 13k minus 3k minus 13 equals 0. We'll group the first two terms together and the second two terms together with a plus sign. Greatest common factor of the first two terms is k, leaves us with 3k plus 13. Greatest common factor of the second two terms is negative 1, so that we also have a 3k plus 13. Now we can take out that greatest common factor of 3k plus 13, and we'll be left with k minus 1 equals 0. So that means either 3k plus 13 equals 0 or k minus 1 equals 0. So we have k equals negative 13 over 3 or k equals 1. Okay, so we have two possible values of k, negative 13 over 3 or 1, where the y value is 5. And that actually kind of makes sense. that means that these 2 points are symmetric to each other on the parabolic curve. Okay, and took a little bit of time to find the discriminant just in case. I wasn't sure with the numbers there. Once we got that discriminant of 256, we could have kept going with the quadratic formula, or we could revert back to factoring as I did in this example. So back to graphing quadratic functions in standard form. Same critical points as in factored form. The order that we find them in changed slightly, and the way that we found the axis of symmetry was different because we used x equals negative b over 2a. But you could also find the average of the x-intercepts, which we had to factor to find. So they took a little bit longer because there was a few more steps, but at the end, we still had all the same points to create that same parabolic curve. So now, practice with graphing in standard form to go through all of the nuances in each example. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.